Hello, everybody. All right, we're going to be talking about solving inequalities, and we're going to be representing situations as inequalities. So if we hop back to 1.4, the last lesson that we did, we had situations like these where we had to find what x was. So if I'm looking at problem 1 here and it says x plus 7 is greater than 12, I have to get that x alone to figure out what the value of it is. So here it's paired together with plus 7, and so I need to get rid of that plus 7 by subtracting 7. And I have to make sure that these inequalities are balanced, and so what I do to one side, I have to do to the other. So 7 minus 7 gives us nothing, so they cancel out. 12 minus 7 gives us 5. I still have my greater than sign. It's going to be x is greater than 5. And we can check our answer by plugging in any number that is greater than 5 in for x. So let's say I plug in 6 for x. Is 6 plus 7 greater than 12? You bet. Is 7 plus 7 greater than 12? You bet. So if we keep going, it'll stay true, and therefore we know that x is greater than 5. This next one here is paired together with minus 3. So to get that x alone, I need to add 3 to both sides. So let's go ahead and do that here. And then we are left with x on this side, and it is less than or equal to 6 plus 3 is 9. All right. Over here on 3, we have 3x is less than 15. So we need to get that x by itself. So the opposite of multiplying by 3 is going to be dividing by 3. So we divide by 3 on both sides, and we get x is less than 5. And then over here, this one's going to take 2 steps. All right, this one's going to take 2 steps. So here we have 6x plus 14 is greater than or equal to 32. So 6 times the number plus 14 is going to be greater than or equal to 32. So the first thing that I want to get rid of is this plus 14. All right, it's paired together with my 6x. So I'm going to subtract 14 from both sides because that is the inverse operation of addition. And I'm left with 6x is greater than or equal to 32 minus 14. Well, that's going to give me 18. And then what I have to do here is do the inverse of multiplying by 6. So here I'm going to need to divide by 6 on both sides, and that's going to leave me with x is greater than or equal to 3. And again, you can plug in 3, you could plug in 4, 5, 6, 7 in for x and see if it works. Let's go ahead and do that. 6 times 3 plus 14 is greater than or equal to 32. Is that true? Well, 6 times 3 is 18 plus 14. Well, that gives us exactly 32. And so, yes, this would be true to start because it can be equal to 32. And if we plug in any number higher, then we're going to get a number that's greater than 32. All right? And so that's what we worked on in the last lesson. We had a few word problems here. And so now I'd like to move on to 1.5, and it's solving one-step inequality word problems. So here are the keys. First off, we need to read the word problem carefully, and we're going to be highlighting key information if necessary. And then we're going to identify the unknown. What are we trying to find out? And then we're going to write an inequality that represents the word problem. And then lastly, we're going to solve for the unknown. So we have 4 steps here. Let's start off in our blue highlighter, highlighting the key information. So last Friday, Arlena had $10. Over the weekend, she received some money for babysitting. She now has over $32. At least how much money did she get for babysitting? Okay, let's start here by highlighting what Arlena started with. She has $10 to start with. Over the weekend, she received money, so she's going to be getting more money and now has over $32. At least how much money did she get for babysitting? Okay, so let's start here with our $10. Over the weekend, she received some money, so we're going to be adding money to that. But we're not quite sure how much money she received. What we do know is that she has over $32. All right, so think about what I could put in place here for my missing value. I could put a variable like x or y, or maybe I want to put an a for Arlena, whatever you want to put. So I'm going to go ahead and put x in here. So now we have 10 plus a number is greater than 32. Oh, wait. That word at least, that tells me that I could also have $32, right? If I have at least $32, I could just have 32. So very important that we indicate that it could also be equal to. All right, now we can go ahead and start. So first things first, I have to make sure I look at what is paired with my x, and that is positive 10. So I need to get rid of positive 10. If I started with 10, that means that I need to subtract 10 from my original 32 that I now have. So when I do that, that's going to leave me with nothing over here except for my x. And on this other side, 32 minus 10, that's going to be 22. So now here I have my final answer. Arlena received, right, because it's asking for how much did she received while babysitting. At least $22 for babysitting. That is an awesome detailed answer. If you just put x is greater than or equal to 22 and then put at least $22, that works too. All right, now let's look at example 2. Chase had an unknown amount of money in his piggy bank. Okay, so we start off with the unknown. That's what we're trying to find out. How much money did Chase have in his piggy bank? So let's see, we could use X or we could use a C, some variable to represent that. He took $4 out. So there's another key piece of information. And now has less than $17. How much money did Chase start with in his piggy bank? So now would be a good time to pause the video, see if you can set this problem up. Remember, it's going to be an inequality with the variable. We already started it off with our missing number, X, the unknown amount that Chase has in his piggy bank. Now, how do we show that he took out $4 and now has less than 17? Go ahead and press play when you're ready to go. Okay, so he took out $4. So it's going to be minus 4. Because that's what happens when we take out money, right? We're going to subtract it. And if you wanted to rewrite it this way, you could also do plus negative 4. Okay, either way works. And now has less than, so that's that keyword less than, $17. So now we need to figure out how much money Chase had in his piggy bank to start. So we need to look at what our x is paired with, and it's paired with this minus 4. So the inverse of subtracting 4 is going to be to add 4. And that makes sense, right? Because if he took $4 out, we'd have to add $4 to his current total to figure out what he originally started with. So when we do that, we're going to be left with just x on this left side of the inequality symbol is less than, and then here we have 17 plus 4. He had less than $21 to start. Less than $21 to start. We know you had more money than that, Chase. All good. Just working on some math problems here. All right, next we have workshop 1. So these are going to be problems that you do on your own. And these ones are one-step word problems. So you're going to first write an inequality, represent the situation, and then you're going to solve for each of these situations. So this first one here is about Max. It says Max wants to buy a new video game. Cool. Wonder what game he's buying. Maybe Call of Duty or Minecraft or Fortnite, something cool like that. He knows the cost of the game is at least $18. Okay, that's an important piece of information. At least $18. So it's going to be greater than or equal to $18. Max has $6 in his wallet. So that's what he currently is starting with. How much more money, so I see more money, so it's going to be addition, does Max need to buy the video game? Okay, so right now I'm looking for how much more money does Max need? What could I use to represent the number that we don't know but we're looking for? That's right, our variable. So you could use M for money, M for max, V for video game, or you could just go to the original of X. 6 plus a number has to be greater than or equal to $18 because we need at least $18 to buy the video game. So we need to work backwards here. We need to think of the inverse operations to figure out that missing value. And so here we have positive 6 or plus 6 matched with our x. We want to get that x by itself. So how do we undo adding 6? Well, we'd have to subtract 6. All right, and if you want to just think of this as a positive 6, still the opposite would be to subtract that positive 6 that we're starting with, because that's going to give us how much more money we need to buy the video game. So we subtract 6 from both sides. This is going to cancel out. Over here on the other side, we do 18 minus 6, and that's going to give us $12. And then here we have x is greater than or equal to $12. And does that make sense? Let's think about it. If Max started with $12 and then he already had that 6, then would he have the $18 he needs to buy the game? Oh, you bet, because 12 plus 6 is going to be 18. And if we had any number greater than 12, right, maybe he got 13, 14, 15 more dollars, he'd still have enough money to buy that video game. All right, go ahead and try out the rest of these problems here. All right. So that's going to be 2, 3, 4, and 5. And then we're going to move on to the next problem here. It's going to be mini lesson number 2, solving two-step inequality word problems. So this time it's going to be a little bit more complicated. And by that I mean there's going to be one more step. So with solving two-step inequality word problems, you're again going to read the word problem, highlighting key information. You're going to identify your unknown. What are you trying to find? And then you're going to write the inequality that represents the word problem. And then finally, solve for the unknown. Okay, so let's go ahead and start with example 1 here. Blake is remodeling his bathroom. He wants to spend less than $900. They even have it in bold for us. That's awesome. So he wants to spend less than $900 on new tiles. Each tile costs $5. Okay, and there is $50 service charge. How many tiles can he purchase to remodel this bathroom? Okay, so we know that it's $50 service charge. So let's start with $50. And then we know it's going to be $5 per tile. So it's going to be $5 times whatever number of tiles we decide to buy. And that's what it's asking, right? How many tiles can he purchase? So let's go ahead and represent the number of tiles we can purchase with the value of x. So we have 5 times a number x plus 50, because remember, that's our original service charge, has to be less than $900. So first things first, I'm going to start with the adding 50 or positive 50. And it helps to maybe rewrite it. So let's go ahead and rewrite it as 5x plus 50. All right, the order doesn't matter when you're dealing with addition, so that's totally fine. And we need to, again, get rid of that plus 50. So how do we get rid of adding 50? Well, we could subtract 50 from both sides. And that's going to leave us with just 5x over here. And then our subtracting 50 from positive 50 is going to cancel out. And then we have less than 900 minus 50 is going to be 850. Now our final step here is to do the opposite of multiplying by 5, because right now we're doing 5 times the number of tiles you could buy. So if we, instead of multiplying by 5, divide by 5 from both sides, that's going to give us the number of tiles that we could have. But remember, it has to be less than this number. So let's see. 5x divided by 5 is just going to leave you with x. 850, or you can think about it as 85 with a 0 on the end, divided by 5 is going to give you 17. But with that 0, it's going to be 170. So x has to be less than 170. Remember, this is the number of tiles that Blake can buy. All right, go ahead and try this next problem out. You can pause it, and then we'll go over it together. All right, here we go. The last problem, folks. So Daniel has $25 to spend at the fair. If the admission to the fair is $4 and the rides each cost $1, what is the greatest number of rides Daniel can go on? Okay, so let's see. He has $25, so he could spend $25, but he could also spend less than $25. And it's $4 to get into the fair plus 1 times however many rides he decides to go on. So there we go. We have it set up. And so here, we're going to want to get that x by itself. So first, we're going to subtract 4 from both sides because that'd be the opposite of adding 4. And so here we're left with 1x is less than or equal to 21. And remember, when we multiply anything by 1, it's just itself. So we can think about this as x less than or equal to 21. That's the number of rides that Daniel can go on. All right, go ahead and work on the workshop here. And thank you for watching the video. I appreciate it.